Thank you, Reshmi, for and very specifically mathematics, very difficult to explain in mother tongue. Expectations are good, but now already 33 minutes gone, 27 minutes gone, maybe 3-4 minutes for vote of thanks. Reshmi is just waiting for that to finish. You could say vote of thanks and finish this program and say one seminar is over. If that is the intention, I am very sorry. Unless I see faces, mathematics will not come to me. No subject, no language will come. Otherwise, I could record and send you a better lecture. You could circulate it along. I don't think it's a technical issue. It's not a network issue. It is a practice. It's not for last 400-500 days. Sitting at home 432 days. Every day I am into webinar. So I wish people have a minimum courtesy to a speaker, that they show the face. Otherwise, I don't know whether I am audible to you or not also. Response is not there. I know there are difficulties. Being physical is always the best, which I like. And Kollam and these places like Chathannur and all is not new to me. I have been wandering around probably from Chavara to Attingal. I must have travelled many times. So I must have crossed the area of your college many times. Unfortunately or fortunately, I couldn't see your college so far. Having seen more than maybe all the colleges, I don't know. I missed this college, and I'm sure I am in your college not because DrTPS is a great mathematician or a great speaker. By chance, Varkala SN College principal happened to be a close associate of mine, and last month there was a seminar on applications of calculus, and incidentally the topic selected happens to be opportunities in or applications in analysis. I don't know how many of you really thought the relationship between my previous talk, or any one student would have heard it, or any faculty would have heard my lecture which I gave in SN College. Any mathematics student, this justifies some of the real good mathematics students are there in this college. Is anybody here who heard my previous lecture in Cherthala SN College on applications of calculus? Raise the hand. 5,000 rupees will be given from me to that person who has heard that lecture thoroughly. I have not seen. I could have given 1 lakh also, right? So it shows none of you have looked at who is this buffalo who is going to talk in the seminar. You don't care, whoever is that. Second, you don't know what topic I speak. And third one, you have no interest in the topic which I speak. It's so pathetic. Even a master's, last month the topic was given to a college where only graduate students are there. But here now we have got postgraduate students. So it shows it's not that way I did my master's. I did it from Cochin University. If I see a topic webinar, immediately I will go and search. Those days there is no internet. Today it's only clicking on the mouse you get the details. But that was not my case. So what I do is I go and look at the topic. Probably sometime I don't even know how to read the title of the topic given. It was so abstract and unimaginably, ununderstandably bad for me. So what do I do is I go and ask the librarian, is there any book in this topic? That's what I do. And then take that book and read. And that's how I learned my maths. Then understand, oh, this belongs to this department, this teacher, this faculty. We had that liberty because we had almost 20 faculties and only 10 students. Number of faculties were more than the number of students. Research scholars are almost equal number. So we always had approach to the highest. And during my mathematics, I loved most of the abstract mathematics. Theorems have to be proved, but I have disproved theorems. Generally, it doesn't happen. And that is how I challenge great authors of the book also. And the whole department did not work for 2 days. Were thinking about how this theorem can be wrong. They know theorem cannot be wrong. But when you give a counter example to disprove a theorem, the so-called great mathematics professors must be able to say that Dr. Shashikumar is wrong. That time I am not a DrTPS. But they were not able to find where I went wrong. Therefore, I could convince others. So I remember my professor called me, Professor Trivikraman, then third day and told me, better you be an advocate than a mathematician. Because you know how to prove wrong things into right and right things into wrong. That is the way I learned maths. We had teachers where I could ask questions and the teachers will come to my hostel to explain the answer. Maybe night. Even today, the few, I think 1.5 months back, my head of the department, Trivikraman, called me and then said, I just wanted to hear your voice, that's why I am calling. We have a group in which we are active classmates and professors, under whom I did my masters. I did a Banach space. That's a topic which probably I can speak. I speak offhand because that's a topic on which I submitted my project under Professor Kaimal, who later became the head of the Department of Computer Science in Kerala University, where my work in Department of Space happens to be not in mathematics, mostly in computers. He visited my department and then gave lecture here to all the scientists, and scientists could not follow what he is talking. And he was talking on image processing, which is the core subject in which we in our research center do research. So my professor who taught me mathematics, I remember Condi de Bourg, the numerical analysis textbook was taught by my professor. That's analysis, again analysis. And that analysis was totally applied in cryptography, image processing, and that we could not understand because that was too abstract. Recently, the person who taught me measure theory, we call him Tamburan because he was from the palace, Tripunithara palace. When he taught measure theory, none of us understood. Because measure theory is such a subject, I don't know how many teachers, how many professors really understand. That is because measure theory is a pure mathematics. Differential equation is an applied mathematics. That's how people look at differential equation is calculus. Whereas measure theory, real analysis, complex analysis are all pure mathematics. That's how when I also understood when I was doing my MSc mathematics. That's quite unfortunate. Quite unfortunate because Even teachers don't speak each other. They don't even look at the history of mathematics. I don't know how much justice I can do in half an hour. If given, I can speak on days together on this. That's because by now you must have seen, I don't look at mathematics as a subject. I look at mathematics through which I lived my life. That's why I am able to speak like this. Calculus is maybe 400 years back. Why did I ask you and challenged you, have you seen my class on calculus and its applications? Because analysis and application is only a continuation of what I spoke in Chathannur SN College last month. That's why I said knowingly or unknowingly teachers made a mistake by giving the title. If title was something else, I would not even ask this, because what I can speak today, I thought if one person would have seen that lecture, my job today would have been very easy, because I can speak to one person. I understand, oh, that person understands what I am speaking. One is good enough. There are maybe 100 people. I don't expect all the 100 follow. If I can change one person, that's good enough. That's what I believe always. If nobody gets it, I am useless. If one gets it, I am useful. If everybody don't understand, I am totally useless. But here, probably that's how I should look at it. Because you have not seen what I did earlier. The basic reason is, calculus is mostly applicable. Directly scientists can take. I also have seen who are the people who are going to speak. I do a lot of homework. Not in terms of what I have to speak, but whom I am speaking. So that I know the background. And I know you are the coordinator of ICQ is a commerce department faculty. I also have given a request for her LinkedIn today, just now. I was only looking at it now. And she did not operate it for last 90 days. And she is also the entrepreneurship in charge. I'm also an MBA faculty. I was a professor of management. I was also a mathematics management. I'm also a mathematics professor in a university till last December. I left it because I don't want to speak mathematics to only names and pictures. I like to speak to people. So I'm happy at least 4 people have the beauty of showing their faces. The rest of them are so ugly, they don't want to show their faces. I believe that and I trust that I am so handsome. That's why I show my faces. And when nobody was showing faces, I also switched off my, first time probably in the webinars, I am putting off my video when I am being introduced, or because I have seen everybody was switching off. It's so unfortunate, no? I left my job, they were paying very good. I could sit at home and then teach. But then I said I don't want to do it because I like to talk to people, not to computers. And it's not that I started maybe 1 year back because of COVID. Probably in Kerala, I am the only one person who propagated multimedia, only one person who authored a book on multimedia teaching, and probably the worst academic staff college director who Kerala had, because I insisted teachers should use multimedia in classrooms. And most of the people think that multimedia is what you speak converting into PowerPoint and then pushing it. It is not that. It is using augmented reality, it is using graphics, it is using interaction whenever the students want them to interact with you. The advantage is it is so flexible. Assume that you wanted this class to be continued until my next program is only at 7:30. 4 hours I can speak on this topic because I don't have anything scheduled next 4 hours. I only have from 7:30 to 10:30 next seminar. And that's on Yoga Day. And that's going to be on United Nations program. Why I am saying this is what you can straight away apply as your ICQ coordinator thought analysis is mathematical analysis. Analysis comes in different words. I am a psychotherapist. Psychological analysis is also analysis. Functional analysis is there in psychology also. When I saw the syllabus functional analysis, I thought it is mathematical analysis. But it's not functional analysis in psychology. That is how you function your activity, your behavior pattern, your character is analyzed. Nothing there related to mathematical functional analysis. Measurable theories are there. Statistics is a measurable theory. That is very closely associated with the measure theory which we have. So there are two subjects which are very abstract in mathematics, the true pure mathematics, but if you want to look at some applications of that, you must look at probability and calculus. That's why I asked, have you seen my earlier lecture calculus? So that this title I can just finish if I relate analysis to calculus. That's how mathematics is done. Always we transform and then say that I have done this problem to this problem, then now you solve that yourself. If I want to solve a partial differential equation, what I do is I convert them into ordinary differential equation and I tell you, you know how to solve ordinary differential equation, now you solve it. Because we know how to transform things. If I want to transform something from domain to a range, if I cannot solve it in domain, I transfer it into range and then solve it there and then get back. Solving in domain is not that simple. That's what is done in relations and functions. And what do we do in mathematics? In image processing is my subject. I'm an applied mathematician in that sense. I've got an image which has got a huge, the whole screen what you are seeing on your computer is an image which I want to solve. I want to make it more clear. How do I do that? It's very difficult. So what do? I find different characteristics of the image. That's an analysis. And I convert them into eigenvalues and eigenvectors. That's a matrix. Any matrix have got eigenvalues and eigenvectors. You know uniform matrix, you know triangular matrix, diagonal matrix. So I can convert this matrix into whichever matrix I want. So image is a matrix. But image is a matrix only when I represent it on the computer as pixels. But originally in the world it is not pixels, it is continuous. Anything continuous is infinite. In between you have got many numbers. That is what shows infinite. But infinite I cannot represent in computer. So if an infinite has to be shown in computer, I have to convert this infinite into finite. If I have to analyze this person, I cannot analyze it me. I have to put it onto computer to look at pixel by pixel, number by number. So what do? This analysis cannot be done analytically. When it is infinite, I convert them into finite things. Then I can numerically analyze it. That's what is numerical analysis. So what is numerical analysis? Numerical analysis is an abstract analysis converted into a finite analysis. Very simple. That's what you learn in measure theory or maybe in continuum mechanics, an application of that. And you see Stieltjer's integral, Riemann-Stieltjer's integral, measure theory. It's a beautiful subject, but unfortunately my tamburan who taught me never understood or taught me like this. But I realized it like this probably quite late when I was doing image processing. So I don't find fault with any mathematics professors, but I find fault with them after even introducing this by me to you. You don't find interest in learning it. Seminars can be there. Yeah, it's not successful when many people many seminars are conducted. One student learns it, it's good. One subject you learn, it's good. Differential equations, I cannot learn the whole function. So what do is make it into smaller fractions and then look at it very closely, some small interval, what's happening. So that's why you have dy by dx, delta x by delta y, delta x by delta t. You cannot see the whole function. So what do? Look at it very close interval and then see how the limit works there. The limit is what? delta t tends to 0. That means I am showing it to a small interval. I am looking at one point. Instead of looking at the whole function, I look at one point. What a beautiful thing is this, you see. I want to look at a continuous function, I make it into discrete and look at it. I want to look at a function, I make it only one point and then look at it. In one point, if this is the way it is behaving, yeah, no, I will not be able to say the whole function is like that. I have to look at many such number of points. Actually, it is discretization. And similarly, when I wanted to add together, integration. Differential, opposite is integration. Adding together, finding the sum. So now I am sure if you look at my calculus applications, I spoke 1 hour. So what I spoke in these 10 minutes, you will understand maybe 1,000 times better than if anybody could have understood from that college. I don't know whether they understood or not. If you don't understand also, no problem. But if you write down some technical terms what I wrote, I don't know how many students, because I am not seeing their faces. If you don't write down all the words, technical words, nothing wrong. I am going to post this also into YouTube. But anything on YouTube, if you want to hear that only as the class, then these webinars are not required. I can post every day hundreds of just classes on different subjects. Because it's only like telling stories to my young child for making them to sleep. That's how I love mathematics. Right? As far as the law of mathematics is what is the reality which you are seeing, which you cannot represent that way, what you call it as an abstract mathematics. That's how abstract mathematics came. That's how analysis. I want to put the continuous function of my reflections of light on my face. That is a continuous function because there is no discrete. It's a continuous function. It's a wave function because light is a wave function which reflects here, and that's what I'm seeing. I cannot do that. So it's not certain that I can put it into mathematics. It's difficult. But as far as it is certain, the way I put on discrete, which is certain, it never represents a reality. Because it's only few numbers of pixels which represents. When you zoom further, your picture becomes blurred. And that is not I am. Even if you look very close to me, you don't see that blurred picture. I am saying like this. But actually this is a quote from Albert Einstein. This is how we visualize. You are a philosopher who understands physics, who understands mathematics, can explain like this. I don't have to remember that quote. I understand the concept. This is how it is. So Einstein said, you cannot represent reality as continuous functions into abstract mathematics as it is. But when you show that, it becomes very clear to you. That is why Leibniz and Newton and such people 400 years back understood calculus. They are the father of calculus or fathers of calculus. Because there is a conflict who says who proved either Leibniz or Newton. There is always a confusion. It is 400 years back. But the abstract mathematics of today as modern analysis, what you learn in mathematics classes are only 100 years old. 150 years old probably, yes. 156 years old. I remember exactly because 100 years before my birth. 1864 is where this came. So it is 156 years old. So is it real mathematics or applied mathematics? Applied mathematics 400 years back came. Real mathematics came later, which a specific problem more generalized and shown to the world is abstract. Many people think abstract comes first and then, no, it is not like that. The problems are solved in the real world very fast. Because they are physics people, they understand. But then how do you generalize a problem? When I want to generalize a problem, I need to make equations. That may become abstract. Because others don't understand, and they are not interested to learn it. That's how applied mathematics came. So algebra is also like that. Why do you want infinite series is analysis. I think that distinction you all understand. If not, what I can do finite is called algebra. What I can do infinity is called analysis. Very simple. So what I do in algebra is a plus b into a minus b is equal to a square minus b square. It is not a minus b into a plus b is equal to a square minus b square. An abstract formula came first. No. When somebody wanted to multiply 64 and 56, 64 and 56, how do you multiply? They multiplied normally. When many such multiplied formulas, solutions came, they found when you have a number which is 60 minus 4 into 60 plus 4 to be multiplied, you don't have to do all this multiplication. You can create a formula. That formula became abstract because 56 into 64 is equal to 60 minus 4 into 60 plus 4. So problem by problem, when you want to solve it, it becomes applied mathematics. When you create a formula for that, that becomes pure mathematics. And what happens? Pure mathematics is being taught in class without knowing the applied mathematics. Yeah, I don't know how you understood. 64 into 56 is actually 60 minus 4 into 60 plus 4. Without looking it, you can solve it. But a mathematician will not solve like that. He will create a formula for that, apply the formula and then solve it. That becomes pure mathematics. That becomes abstract mathematics. So algebra is also abstract sometimes. That's why you have got a lot of theorems in pure mathematics, which you call it as pure mathematics. Linear algebra, Ian Hastings. In that only I disproved theorems. So Ian Hastings is a Pidamaha of algebra. Where is this poor man disproving it? Because you can find an example where it is, yeah, you can confuse people. Now what happens in a differential calculus? You have got lot of things which represents reality. They solved it, and that was solved by the great mathematicians. And that's what I explained last. And why people hate applied mathematics? Because you understand the concept and the real life problem relation. If you don't understand, it becomes like Tilagan's movie. What he said is mathematics is the spandanam and all that, but you don't understand where is the spandanam there. That's why a minus b into a plus b is equal to a square minus b square. Where is it applied? It's not applied anywhere. It's pure mathematics. It's applied in day-to-day activity. When you don't understand, it becomes pure mathematics. When you apply it, it becomes applied for you. Unfortunately, teachers do BSc, MSc and then start producing BScs and MScs. That's it. Because they don't apply. If I have interest in Hindi movie, my job is to find out who is Amitabh Bachchan. I cannot be in Hindi movie lover and without knowing Amitabh Bachchan's life history also. I should also know what he has done in his life. So if I am sure somebody who is teaching or who learned real analysis for many years may not even know who started real analysis. You are seeing a movie without even knowing who is the director, who is the story writer, who is the playwright, where is it shooted. No. That doesn't show your passion. So if you are writing mathematics exams and taking a PhD to get a degree for you and to get a job and salary, that's different. That's not what I did. I loved mathematics. Though my PhD happened to be in fluid mechanics, application of probably differential equations, more of physics than pure mathematics. And I am talking probably the real analysis after 40 years or maybe 30-35 years after I left my measure theory classes. But I don't require, because it's imprinted. It's like a cinema which you have seen, which you never forget. Only when you visualize it. So when you learn for examination, you forget after examination. I wish one student after a seminar comes back and says, one appreciation. No. Because everything is like a class. That is what is essential. So what is application? Application is when you realize, you feel for that. So why real analysis is difficult for many students? Because you don't feel it. So it's boring. You don't have feeling, it's boring. Either you hate it or love it. If somebody hates and you feel that you are going to fail in that, come to me. Sit with me for half an hour. I will make real analysis as your loving subject. Otherwise, it's only proving theorems without understanding why are you doing it. Many equations, many formulas, confusing, too many rules, so many worksheets, too boring. Mathematics is boring. There was a very good article when I was doing my masters. Pure mathematics is useless mathematics. And ultimately, it's a reductio absurd method in mathematics. You say something, I'm sure when somebody says pure mathematics is useless mathematics, applied mathematicians will be so happy and they read it. And any pure mathematician who love pure mathematics also will read it. So that's the way the title has to be, so that people get attracted. Then what do? While reading, at the end, it proves that there is nothing called pure and applied mathematics. It is one and the same. So there is nothing like applications of mathematics, because mathematics doesn't have a life of its own. I repeat, mathematics is only a language which is used for speaking out physics, chemistry, biology, commerce, anything. If statistics is to be dealt, you need mathematics. If biology is to be dealt, you need mathematics. No subject in this world. If English also has mathematics. When I was teaching English, there were a lot of PhD English scholars. They kept on giving me words, and then I said, that's mathematics. And I challenge anybody who can give me one word, I will say that's mathematics. I said tenses. I teach English. After my BSc mathematics, I was teaching English. I know probably to teach English much better than mathematics, because I am a firm mathematician. I can apply mathematics in English. And that's why I taught tenses. You know what's tenses? The present, past, future. What is present, past, future? It's in the time scale. So time scale is mathematics. What is history? AD and BC. What is AD and BC? Before Christ and after Christ. You put a timeline, put 0 here, put AD here, BC here. That's it. That's mathematics. Any subject, geography. After all the PhD in mathematics, I joined Department of Space. My job was to take satellite image and then look at the Earth and then make maps for Earth. All the Kargil wars, I made maps. How do you make maps? It's geography. What is geography? Mathematics. So where is application? If you know where is it applied, you believe that that's how the English classes. There may be English teachers. If not, ask your English teachers to listen to this class. English is only a language which is useless. Where humanities have to be taught, you use English language. If I have to express, I need a language. If I have to express knowledge of maths, physics, chemistry, biology, anything, I require language. So calculus is a language for expressing anything which you have in reality, using either engineers use it or scientists use it, or all the applications of mechanical, physics, chemistry, biology. Even in ecology it is used. And all that what you use it really, like a minus b into a plus b, 64 into 56, how did you multiply? Now I want to make an abstract science of it. The whole calculus is made into abstract science using real analysis. Very simple. So what is real analysis? Now if you are not good in calculus and then you learn real analysis, you can't understand real analysis, because it's a generalization of calculus. I'll tell you, I guarantee you, you listen to thousands of lectures, you will not get this view. Because I experience mathematics. I experience this. From that only I am speaking. There are few professors who understood this. And that's why my MSc thesis happened to be, you know what is metric space? Metric space is a set which can, I remember my first assignment in my MSc class was, all set can be made into a group. That's a basic theorem in algebra. Every set can be made into a group. So what are the examples given for a set? all students in the class is a set. So immediately that definition and what this definition, I started connecting. Oh, we had a few children, students in my class. 11 students. Can I make these 11 students into a group? That's what I thought. Immediately I raised my hands and then I told my sir, I will give a seminar next class. And that is making this class, MSc class, into a group. So what did I do? When you make it into a group, you need a null element. So I found a very lazy boy. I kept him as null element. And all the boys and girls, for every boy, I found a girl. And I made them into a positive and a negative. And when they react, you get a null element. So I made a group. And when I made a group, every group can be made into a Banach space. Higher algebra in real analysis. Measure theory you will learn. Banach space you will learn. What is Banach space? I can find a distance, and distance is measured, it becomes Banach space. Metric space. You know what's metric space? A complete metric space is called Banach space. Yeah, I am remembering my formulas and theorems, yeah, just like that. It's nice. A complete metric space in all the metric. What is metric space? A minus B, that number is also inside my set, it is called a complete space. Got it? So 2 minus 3, 1. No. 2 minus 3 is minus 1. So if it is not there, I add that also in the set. So all that formula. Therefore, all the prime numbers, all the irrational numbers, rational numbers, all the counting numbers will not become a Banach space. All the numbers together will become a Banach space. That's one example. So what do? I can find the distance between them. Wherever distance can be found, I can define calculus. Because distance by the small fraction, how does it behave, is calculus. So what I can do, you take that real analysis, which is a metric space, a set and a group and all that, you define vector there, direction there, metric there, it becomes a vector space. It becomes a Banach space when all the solutions are inside. In that you can define differential equation. See, you must be thinking how this man is telling like this, right? That was my project during my MSc. Very simple. So I was so happy when this topic was given. I don't even have to read at all, right? Because this is my project which I am explaining. That's why I said nobody asked me to explain this project. So that's application. So if differential equation has application, and I can generalize this differential equation for mathematics people. So unfortunately what will happen? A minus B into A plus B is equal to A square minus B square, only mathematics people learn. They only apply it. But 56 into 64, everybody computes. There are a lot of people computing 32 into 28. Everybody does it. Because it's a real life problem. But mathematicians, what they will do? Convert it into a abstract space and then solve it. So how do you understand real analysis? How do you understand functional analysis? How do you understand complex analysis? Do that. Now what is complex analysis? Now when I am talking to you, there is a wave coming to you, and that wave is what is giving my picture, what is giving my sound. But when you draw a wave, generally draw only like you draw x-axis and y-axis and then draw like this and then wave is like this. Who said the wave only goes in linear line? It is in space. So it can also go in all the 360 directions, right? Only thing, when you take a cut on the wave in the sea, you will see it as a line. But wave is not a linear phenomena. It's a different phenomena. At all the directions it can go. So if I draw one wave in the x-axis where the trough and the frequency is measured on the y direction, that's fine. Now you take a 3 dimension. So what you do is you draw wave in the other direction. You draw wave in all the 3 directions. How do I represent this? That's where I need a complex analysis. So one wave in the x direction with the y-axis as the frequency, no problem. All images are like that. Because you are seeing me only a picture which is on your computer. I am 2 dimension. So my picture is a 2 dimension for you. But my picture is not 2 dimension. I am a 3 dimension fellow. My hand is coming forward, but it is getting projected into 2 dimension. So it's a projection on a 3 dimension to 2 dimension. That is good enough for your analysis. But really you want to analyze what is in the real world, XY axis is not good enough. I want to add one more axis, and that axis becomes Z axis, and in which I have another wave which I wanted to represent, that becomes imaginary axis. And that imaginary axis, all the images which we take from satellite, only optical region 0.4 to 0.7 which I take a picture and print it and keep it in front of me, that becomes real analysis. But radar pictures, you want three-dimensional pictures, that becomes a complex analysis. So where is it applied to complex analysis? All image processing solutions, complex analysis. I'll show you hundreds of examples. That's a everyday job for us. It's like making chapati for, dosha for you or idli for you. Complex analysis is something which we use every day. Everyday life. Should I stop? It's 4 o'clock. 4:08, sorry. I was just seeing time.
So please continue, sir.
Okay. With your permission. So, how rich is your complex analysis? How rich is your real analysis? How much computational is that? Yeah, I cannot compute anything without that. So what do? A continuous function, you make it into a continuous function. Integration is, now what is integration? If you draw xy axis and then draw a line, that is y is equal to mx plus c. What is y is equal to mx plus, okay, let make it, m is the slope and c is the where it is shifted in the y axis. Now not required. You take y is equal to x as a line. Simplest line. Y is equal to x. That means 45 degree x axis, y axis, you are drawing a line. Now what is integral of y, integral of x dx? X square by 2. What is x square by 2? If I draw x axis and y axis, draw a line, take 1 unit here, 1 unit here, that becomes a right angled triangle. The area below the line projected up to the x axis is the x square by 2. That is the area of the triangle. Because x is the distance, x square is the area of the square, and half of that is what the line is. So assume that I have got a line, wave like a function going like this. I cannot compute this so easily. So what do? I cut it into smaller pieces. Any village officer who comes and survey your land exactly using analysis. If there is a land which has got not a normal triangle structure, rectangle structure, circular structure, it is the boundary wall is not a normal mathematical function, mathematical graph. It has got a different wave patterns. How he will compute the area? He will cut it into smaller pieces and make it into rectangle and triangle. That is what is Riemann-Stieltjes integral. You look at it. You look at real analysis, measure theory, Riemann-Stieltjes integral. That is computation. How do I compute it in numerical analysis? Same way. I cut it into smaller pieces and see where the function is changing its sign. If the change of sign is not much, then I will take that, and I don't know how the slope changes. So what do? Find dy by dx whether it is positive or negative. So I know the curve is going up or curve is coming down. And d square by dy by square, where it becomes 0, I know drastic change is there. So I cut there and take this portion separate, that portion separate. So my division is done based on the calculus, and once it is defined, I take it into number of pieces and use it in numerical analysis. That's a logic. And what is this logic? Abstract logic. Who understands this abstract logic? Who learned mathematics? Who is an analysis man? That's how we analyze. Every complex valued continuous functions, systematically I cut into real defined problems and convert a limitless or maybe unlimited, infinite number of problems into a finite algebraic problem, and then numerical analysis can be used. I don't know how to repeat it. It just comes like this. Yeah. So calculus is the subject of real analysis. Yes, calculus is the subject of real analysis. But calculus came first. It's like son came first and father came later. Calculus came first, then real analysis came and told this is my son. you put under me. Therefore, that became abstract. Even calculus became abstract because people started learning calculus as abstract. So analysis is the process of deriving a meaningful information from what you cannot otherwise conceptualize. I am a philosopher. I take more classes in philosophy than mathematics these days. You can listen to my philosophy lectures. And this comes only when you understand the problem, not learn. Don't learn. I make people to understand mathematics. Otherwise, I am sure you can't visualize like who invented the modern, who is the father of modern analysis? I remember the date because 1864. 1964 is my birth. 100 years before. So, that's a time when the real lectures started by who? Weierstrass, I don't remember the spelling. Weierstrass is the name. The Weierstrass. No, wasteful Weierstrass we say, right? Distress, like that. So it's like Weierstrass, I remember the name Weierstrass, who is called the father of. What he did do? He was a dropout from college. And what he was doing? He was taking tuitions in mathematics, physics and botany, and he was a gymnastics man. More relevant because these days I do lot of research on gymnastics and yoga. Actually, yoga is gymnastics today. There is lot of conflict. The other day we were fighting whether it is gymnastics or yoga or gymnastics. That is because in Mysore Palace, lot of gymnasticians came. They talked to yoga people and convert all of them into yoga. And that's how Iyengar started yoga. Actually, this is not yoga. It's only gymnastics. Yoga is not at all physical exercise. Like I've got maybe 5-6 years back, I put a video saying that yoga is not a monkey's job. Unfortunately, it has become monkey's job today. You have to put your leg on your head and all that, right? So it's like that. He was a gymnastics man because he couldn't earn much. Today, no. Today, yoga is paid more than mathematics teachers, right? Those days, mathematics was less paid. So he became a gymnastics teacher. But then he found, lot of theorems. And that theorems he made into a structure and started teaching into universities. He was a German man. Yeah, he was a German, I think, yeah. That time, by then already, the Riemann, Newton, Laplace, Gauss, all the mathematicians and physics people were into the job. But what he did was, he changed all that into complex mathematics. So if somebody has got hatred towards real mathematics, you must excuse the Weierstrass and then tell him, kick him and say that this man created all the trouble. Yes. It's only 100 years back he created all the trouble, and then he started explaining analytical functions, elliptical functions, Albion functions, calculus of variations. Otherwise calculus was there. Calculus of variation was not there. Applications of elliptic functions. And he analyzed all the functions under him. That's how the real analysis came. And that is hard because you have not gone through the calculus thoroughly. Because calculus you thought only sine dy by dx of sine is cos. Good enough. No, that is not dy by dx of sine is not cos. Minus cos is not sine. What you should do is identify dy by dx at every point and then draw the curve. Then what you will get? You will see the curve goes like this. The reverse it goes. And you put them together, you get a circle. So what you do? You take a circle, cut into half, take this half and then reverse it and keep it. You get two lines like this. Cut it again and reverse it, you get another wave. And that's how the waves are created. So it's only a circle. So sine and cos is a circle. Trigonometry is a circular job. Otherwise, triangle is only having lines and angles. Trigonometry has got what? A circle and angle. That's it. That's the difference. So if you understand trigonometry in that way, you understand why calculus and trigonometry is not understood. Finished. Then you don't understand why cosecant becomes secant, secant becomes tan, tan becomes cosecant. All that becomes so much confusing because you did not realize it as a function and you are not seeing it as a line in front of you. And all that if you understand Fourier analysis, use your analysis because it's full of expressing these into. I remember long back I was teaching all the mathematics teachers who were teaching engineering college, teachers of mathematics. I did a Fourier analysis, maybe 1990s, yeah. 1990s I gave a 2 days workshop on Fourier analysis. So I asked them, have you seen Fourier analysis? Seeing Fourier analysis, sir, we never see. Have you have old radios in which all the signals are moving like this? That's Fourier analysis. That's Fourier analysis. You see this, the signal goes up and down. What you do? You cannot solve it in the normal domain. You convert them into Fourier domain, solve it and then come back. That is what inverse Fourier transforms. So all the functions and transforms, I cannot solve it here. I change it to a different world, bring it back. That's what you do when you take a e power. All that logarithm is that only. You want to multiply two things, convert them from your domain to a other world. There you don't have to multiply, you can add two things and then come back. So you want to multiply two items? No. What do you do? Find the logarithm, go there, add them together, come back, and then you will get the solution. What a great idea, yeah? So what is functions do? Functions solve your problems. But what mathematicians think? Functions means very difficult. But as an applied mathematician, when I look at it, what my problems are made so simple. So when you look at an image, now it becomes too complex for me. So what do? I take all the functions of that, check, and then create a abstract space. So Fourier series is a daily job which we use for solving most of our image processing problems. Fourier analysis. Look at I am not blah blah blah. All the terminology what you should do is put Fourier analysis, image processing. You will get big books, not small chapters. We have got big books on Fourier analysis and image processing. All the continuous functions. How do I know the center of what do we do? You take a picture in the Kargil. You know the earth is rotating. What speed? Too fast. You want to know the speed of earth? 6,200 is the radius of earth. 2 pi r is the circumference of earth. That much distance is traveled in 24 hours. So you know, you have taken compute. I don't remember, I compute. So you compute it. In that speed, the earth is moving. And satellite is 800 km higher. So you must know, and earth is revolved around by the satellite in 1.5 hours. It's not 24 hours. So a much faster speed, nearly 15 times, 20 times faster satellite is going. So imagine somebody is running and I am running behind. Anjana is running and I am running with the camera behind her and clicking pictures. Will the picture will be clear? Nothing will be clear. And that picture is what is coming to me. And I am supposed to make it very clear and then find where the road is, where the car is parked. How do I solve this problem? I have to put them into different structures. And that structure is transformation. So I transform from a moving to a non-moving. Project it from a 3-dimension to 2-dimension. Are we not doing this every day in our analysis? 3-dimension to 2-dimension, one domain to another domain, range to range, solve it there and come back. Oh, you get solution. So I'll tell you this is in this latitude, longitude, this tank is parked. That's how we detect things. So what is used in every day is abstract mathematics? No. It's a pure mathematics. Abstract mathematics. But you engineers don't see them as abstract. They see them as calculus. They see them as probability. They see them as matrix. They see them as algebra. But when you generalize it, the pure mathematics generalized becomes a real analysis, and that real analysis is a topic not of interest to any engineers. Therefore, engineers don't learn this. Unfortunately, I am a pure mathematics lover, happens to be an engineer, and my PhD happens to be in applied mathematics, and approximations we do for real analysis, it becomes a calculus. That I understood basically in my life. So I request all the teachers to understand applications and opportunities of real analysis is you can become a problem solver in every situation. Otherwise you solve problems picking up one by one. If you are a real analysis man, you make it a generic solution like a minus b into a plus b is equal to a square minus b square. Solve all the problems. I am only giving one example because too many examples will confuse you. So I am taking the same example to show you. So what is infinite cannot be solved. Finite can be solved. Finite is solved by real engineers and scientists. When you convert them into limits, continuity, differentiability, real functions, and that becomes a rigorous theorem, limit points, etc., you will talk in that, because you have got infinite, and that limit point is finite, functions are infinite. Understand this, that is analysis. So what do they generally come in real analysis? Limits comes because you want to make it into point. Lot of related theorems will come. All the limit theorems, whichever subject you take in analysis, limit theorem is normal. Differentiation I explained, integration I explained, measure I explained, infinite series I explained, all Taylor series, all that is Fourier series, all of them are that. Analytic functions also explained. Is there anything else which I left? Topological space, I am leaving it because it's by itself is a metric space where you don't have a definite rule. That's why we say a cup and a vada is same, right? Because it only measures the holes. Now when you take it and then identify the number of points which is bisecting and then putting together, that becomes graph theory, and they are called nodes. That's called a degree theory in abstract space. So my MSc project was differential equations in degree theory and Banach space. So degree theory is number of nodes, where is it cutting, the metric space. Is good enough? I think that's good enough, unless you have some questions here. And I loved Royd and Rudin and who? I think Upstall. Measure theory is from Upstall, right? Tom Upstall, I think, and Simmons. All these are like, I remember even the cover page. One round there, another round there, another round. Because I remember after the first complex analysis and such topics were taught, what I did was, those days even photocopier, Xerox machines were not very common. I had to walk 3 kilometers to get a Xerox machine. University also did not had a public place where I could reduce and enlarge. That was a great invention those days. One-to-one copy was available. But I want to give a great gift to my teachers, mathematics teacher. I remember A. Vijay Kumar, who was head of the department. I gifted him a paper for teaching me complex analysis, Chowdhury's book. What I did was, I went to library, borrowed book by book, only limited 4 books per day. So 4 books I will take, go to Xerox shop, take the photocopy of the cover page, reduce it into small piece and make a small matrix album. And created many such books. All of them cut and paste on a paper and then pasted a nice picture, which is a beautiful picture, and then that I gifted to Vijay Kumar as a gift. I remember after 30 years when I went on his table under the glass top, he must have changed his table many times. Still that was there. And he says, I every day remember you. And that's how I loved my mathematics. And those books were not taken just to Xerox. You ask me any theorem from that book, I knew that. I don't know whether I remember now or not, but if somebody can challenge me, yes, give me 2 days, I can remember. Right? Though unknowingly, while introducing, many people said this is a real expert. I never thought I am an expert. I thought I am a pert. But I still remember what I learned long back. So it's an X mathematics for me. I don't use them every day, but I use without knowing into my computer programming, into my numerical analysis, which also I left maybe 10 years back. I left my job. I am no more a scientist in space department. My wife is. My wife does a lot of mathematics. Yeah, good enough? I can go on and on, unless I don't know whether somebody is listening or not. I don't care, because I am enjoying, though you are suffering. Mathematics classes are like that. The teacher don't enjoy, students definitely suffer. Even if you don't enjoy, they will suffer. So what do I do is, somebody has to enjoy, right? So I enjoy mathematics. And it's a great credit for me, because I am going to put them into YouTube. So otherwise, every day I have got yoga classes, philosophy classes, maybe different psychology classes. But getting mathematics class is something, yeah, rejoicing my old memory. It's like going back to my hometown. I wish one or two questions. I love it. Now I am sure at least one or two will look back my calculus class, but that was not this good. I made it good because at least a few smiling faces are there. Yeah. That day it was heavy rain, so most of them could not get. And I also improved probably. Yeah. One month back I learned calculus. Now, yeah, real analysis. So unless you have on first step 400 years back, now 100 years back. Yeah. That's it.
Thank you so much, sir. It's very interesting. I am not a mathematician, but being a chemist, we have a lot of mathematics also. But
yeah, I will teach chemistry much better than mathematics. I don't know, as a chemist, Lata Miss has seen atoms in your life.
Yes.
Did you see atoms with your own eyes?
Yes. In the AFM and all those new electron microscopic equipments, we can see.
No, without equipment we can see. Kanadhan saw atoms without equipments. जलांतर गदे भानौ यत् सूक्ष्मं दृश्यते रजः तस्य त्रिंशत्तमो भागः परमाणु इति स्मृतः. Parmanu is atom. Jalandhara gade bhanu. Take a small slit of light and put in a dark room. When your projector projects, you will see small particles moving. That's called rajaha. You take a bucket of water, put a torchlight, you will see small particles moving. That is called rajaha. Tasya trimshattamo bhagaha paramanu iti smritaha. Imagine that is 300 pieces, made into 300 pieces. That is one atom. That exactly becomes between 10 power minus 9 to 10 power minus 13 micrometer. That is mathematics. Micrometer is mathematics. That is the size of an atom. So that's full of mathematics. And if you don't understand, there is another one more line to be chanted. Jnani nam drishti gojaraha. Buddhi lake manasilavullu. So everybody will say, yes, I have seen atoms.
There is another interesting title like nuclear NMR. You learn the theory of NMR.
Yeah.
And they are being converted to magnetic resonance imaging, MRI.
Yeah. My son is a nuclear scientist. My son is a nuclear scientist in America.
Yeah, and I heard there is mathematics that converts this.
Full of mathematics. Full of mathematics. Actually, he is a mechanical engineer, BTech in mechanical engineering, changed into material science, that is full of chemistry, and then changed into nuclear science. And he is a nuclear physics scientist now.
Yeah. Really, mathematics helps a lot.
Mathematics is only a language. Actually, mathematics is surviving because other people are using mathematics. But unfortunately, mathematics teachers think that no, they can stand independent. So, if mathematics teachers learn little bit of other science, you will enjoy mathematics much better. Every problem in mathematics is related to something which somebody has done previously and then made into a generic formula. That is mathematics. That's why we have got Newton, Leibniz, Gauss, Simon. Everybody was physics people or somebody else. Not mathematicians basically. Good, thank you. At least chemistry people also enjoyed. My cousin brother is one of the best chemists in India. He is Professor T.P. Radhakrishnan. I am sure any chemist will know his name. And he is in Central University, Hyderabad. He studied where Einstein studied. And my son studied in the college where Madame Curie, Marie Curie studied. They were all in London, Imperial College and King's College. Yeah? Any questions? Any questions? Any discussions?
Sir, one small doubt.
Yeah.
Sir, you said every second we can convert every second into a group. How
Yeah.
can we convert a natural number and addition into a group?
Only thing you have to define you have to define your function accordingly.
Okay, okay.
See, the group has got an operator. When you are see 0 and 1, only two numbers. I can put a modulo 2 as the operator, right?
Okay, okay.
Ennamma, Reshmi. Very simple.
Okay.
I have only computer science, I have got 8 digits only. 1 bit and byte. 0, 1, 2, 3, 4, 5, 6. That's good enough. I can put it into modulo. The bit is what is only 8-bit display. What am I doing? I am putting all the numbers into computer into 8-bit. Reducing the whole number. I don't put the whole number, right? So 2 power 8 to 256. That's how it is done. So everything I define my operator. Anyway, we are doing abstract. So I can do operator as I want. Thank you for reminding. I would have forgotten all this if you don't ask. See, when you ask question, I don't know that's the answer. I am not, see, Rishmi, I am not answering from my brain. I am answering from my manas. No. Answering from my atma. It comes from my atma.
Okay.
Manas also only keep something which you really wanted to keep. My mother's picture in my manas. Because every time I refer it. These are something which I don't even refer. So when we don't refer, we put it into brain. I don't put it in my brain. Bhagavad Gita, there is a big, most essential sloka in Bhagavad Gita. Uddhared atmanatmanam, atmanam avasadhayet, atmaiva hyatmano bandhu, atmaiva ripuratmanaha. I love or hate, I put it into my manas. Remember all of them. But when it becomes too much, I put it into my atma. When you asked, I couldn't know what is the operator which I have to tell. But the answer came modulo. Good enough. Yeah. So I don't forget. That's why I said give me some time. Good question. That's a thoughtful question. That means you heard what I said. If somebody don't have network or some problem, you could also put it onto chat box. I live in these webinars because every day I have got multiple sessions. Look at my YouTube, you will see variety of things every day. People who want to go abroad for studies, what do I study? Yesterday, mechanical engineering students. What can I study? How do I change my subject? There are people, because of they lost a job, 5 years, 10 years of experience, they came back home, now don't know what to do. So yesterday I had somebody who was thinking of what to study next. So a lot of dialogues. Why I am saying this? Anybody could come back, ask me questions. That's what I do. I'm a life mentor. I guide people to or make their goals better so that they can reach out as best as they can do. Yeah. Are pre-fusion weapons possible? See, weapons itself, fusion and fission and all is pure. Okay. I thought they are asking fusion and fission. Pure fusion weapons. What does it mean? Priscilla Pacifica. What is that name here? Is it a Indian or? I did not get the question. Can you explain? Come on to video and explain. That would be better. Nobody? There was one question in the chat box, but I wanted to respond to that based on the way he responds, or he or she, I don't know.
Sir, one minute, sir.
Yeah?
Sir, I would like to know about the analysis behind our Itihasa.
Which one?
Analysis behind Itihasa.
There are plenty of. The yesterday or day before yesterday I spoke about Idihasa, Purana and Sankalpa. Just look at my yoga posting. Maybe send me a WhatsApp. I'll send you the. And you are Rani? Yeah, Rani Rajivan. I posted already to you. You must have not listened. I already posted to you. Once I get a contact, what happens? I keep posting. So it's already there in your. The other day I spoke on the Sankalpas. So most of them are Sankalpas. Idihasa Puranas are all Sankalpas. Most of the puja which we do are all full of mathematics. I don't know how many people know this. Do you know this? All the chantings which is done by pujaris inside the sanctum sanctorum, if you listen carefully, they don't know that is mathematics. If you know mathematics, you know that's mathematics. You want to know?
Yes, I would like to know.
They chant Rudra mantra, which is called Ekachame, 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 Trishashtame, 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 Panchachame, Panchachame, Saptachame, Saptachame, Navachame, Navachame, Ekadashtame, Ekadashtame. You heard this many times. If you go to temple, you will hear. What is this? Ekachame 1, Trishashtame 3, Panchachame 5, Saptachame 7. This is arithmetic progression. And some God doesn't like arithmetic progression. After arithmetic progression, what do we learn? Geometric progression. Ekam cha, dasham cha, shatam cha, shatam cha, sahasram cha, ayutam cha, prayutam cha, niyutam cha, kayutam cha, atrayam cha. You know what is it? Ekam cha 1, dasham cha, shatam cha, sahasram cha, ayutam cha, prayutam cha, kayutam cha, vayutam cha. It's all 10 power. 10 power 56. Up to that, any priest will chant. This was geometric progression. So harmonic progressions are also there. So it's so wonderful. Our puja vidhi had lot of mathematics inside. And vector calculation. Any normal Surya Namaskara when you do yojananam sahasre dveshade dveja yojane ekena nimishardhena kramamana namastude. Yojana is the distance. One yojana is, look at how much one yojana definition. You can Google. Yojana is already computed. Yojananam sahasre dveshate dveja yojane. Dveshate dveja yojane sahasre. So 1202 yojanas. 1202 multiplied by the yojana. 2.8 kilometers. One yojana. Ekena nimisha ardhena, half of a nimisha. What is half of a nimisha? The time taken for your eyelids to go up and down. That is 0.14 second, half of that nimisha, 0.28 seconds. National Science Academy already determined it. You get velocity of light. Hey Surya, namaste to you who is traveling in this distance, this time. That's computation of velocity. So we had in our puja vidhi lot of mathematics, lot of physics, lot of science. All the Aryabhata was a great geography man and mathematics man. Geography is astronomy. When you do it on earth, it becomes geography. When you do it in the space, it becomes astronomy. That's all the difference. And he also computed different layers of atmosphere and how much is the earth up to the toposphere, up to the atmosphere. Avaha pravaha uddhastada paripurvagavahu. When people think these are all some chantings, these are all physics and maths and chemistry. Okay.
Ready?
Is it good enough?
Straight university.
Sir, last.
Yeah.
I'd like to know the Shiksha program in Kannur district.
Yeah, I have got a program, Shiksha Nanam program. That's what you are asking. Did you ask that Shiksha at Nanam?
In Kannur district.
Yeah, Kannur district, what I am doing. Is that you are asking? Yeah. I wanted to go back to my hometown. So I thought from Kannur it is nearly 45 kilometers. It's in the Western Ghats. So I've got an old house, nearly 200-year-old house. So what I do is I do a lot of camp programs there. That is where the Varkala principal stayed in my house for 10 days on psychotherapy program. She was learning counseling in my house actually. So that place is like a hermitage. Many people can come and stay. So I conduct a lot of camps. very specific camps. It could be subject wise, it could be general learning, it could be anything. So based on the requirement, we put a camp together. You can see what happens. The prize is called at Nanam. Jnaanam. Nanam. Nanam is knowledge, but Nanam is Janaki Narayanan mentoring. Janaki is my mother, Narayanan is my father. So Janaki Narayanan mentoring. That short form is Nanam. So what do we do generally? I cater to three set of people: teachers, parents and students. That's why my name is TPS. Okay, that's what I do. Good enough. So at least I find few people have got some few questions. So glad. I wish the master students and all should have lot of. You can take any chapter, any problem, anytime. But don't send me, this is problem, solve it and send it. No. I like to explain and make them to understand. If somebody wanted to understand the problem, come to me. Not solving problems. Solving problem is routine. So anybody could get to DrTPS. To get my number, Google DrTPS. Temperature pressure second. Top police service. Talli police Shashikumar. That's it. Teachers, parents and students. Or you want topological space, TPS. I just made it now. That's it. Okay? Enjoyed?
Audience, more questions, please.
I can stay as long as you want. I told you, I have got another maybe 2 more hours I can stay. Any questions? Generally, no. Kerala students don't ask questions. They know everything. Or they are not interested. Right?
Sir, Rishmi from Kannur.
Oh, where are you from Kannur, Rishmi?
Sir, I am from Pedaur.
Peravur, yeah. I am from Naduvil, Naduval. We are neighboring districts. Yeah. I mean neighboring places.
Okay.
Yeah. Irikur alle? Irikur Niyojakamandal alle? Peravur Irikur Niyojakamandal alle? Peravur Niyojakamandal.
Sir.
Next is Irikur, so I belongs to Irikur Niyojakamandal.
Okay.
Naduval, Naduvil. That's my place name. That most of the people know. Naranayingane Jenichu Bhumil Naragavaridi Naduvil Nyan. Naduvilan. Naduvil Jenichu Ondana and Naduvil. Adtha Lina and a column better. E Naragatil Nin and a corrugated. Angana Nalona Prartichon out and then I did the charges on Portik. That's why I went out of Kerala. Naduvil High School belongs to me. That's my school. Kollam I came to many places. I think Women's College I came. And I came to Fatima College. Fatima College I gave a WWS program. I was one of the mentors mentor. So I made a program called Mentors Navigation Workshop. What I did was I want to make a cluster of teachers and then start telling what mentors can do. So I made such clusters throughout Kerala and identified a few colleges. And I was traveling throughout Kerala. So 2018 I think, yeah. 2018 I have driven nearly 6,300 kilometers in Kerala. Kerala is only 400 kilometers. So you can imagine how many times I went here and there. 2016, yeah. 17 January to March. So 2017 January, before the Youth Day, on 11th I came to Kollam, Fatima College. That's how I remember. So every day I was traveling, talking to different.
I attended that class, WWS class.
And you don't, my class you attended?
Yes, sir.
അത് കഴിഞ്ഞ് കോണ്ടാക്റ്റേ ഇല്ല. Nobody has sent me a message. അതാണ് കേരളത്തിന്റെ ഗുണം. You find somebody is useless. He did her job. Probably I must have scolded people there. I scold all the teachers. So they think this man is very dangerous. Correct? You attended in Kollam or Kannur? Kollam only. Kollam was a good audience, but SN College Kannur was the worst place where I had my program. Then I decided I will not go towards north. Kasargod I didn't go at all. I cancelled my program. Best place was Kottayam. When I did that second, again they wanted. So Basilius College I did, CMS College I did, 3 colleges I did. Maybe one cluster was not enough. Many people wanted to attend. All of them are there. What I posted, you can look at Reshmi's picture. Now I will look at you. That is there on YouTube. What I did may be there on YouTube. You can look at. If at all you have opened up your mouth. Otherwise may not be. Which department, Reshmi? Mathematics only?
Yes, sir.
Okay, good. Good enough?
Thank you, sir. Thanks a lot. Next, I invite Yasmin for what happens. Good afternoon, everyone over here.
വോട്ട് ഓഫ് താങ്ക്സ് പറയുന്ന രശ്മിയോടാണ് ഞാൻ അൺപാർലമെന്ററി ആയിട്ട് കൊല്ലും നിന്നെ എന്നൊക്കെ പറഞ്ഞത്. അവളാണ് ഇപ്പൊ താങ്ക്സ് പറയേണ്ടത്. ആ പറഞ്ഞത്.
Respected Principal Dr. MS, Leather Teacher, Honorable Chief Guest DrTPS sir, IKC Coordinator Dr. Parvati Teacher, Department Head Dr. Ann Teacher, and all the teachers and dear my students. It is a great pleasure for me to have an opportunity to give vote of thanks for this webinar. On behalf of Department of Mathematics, I extend a sincere vote of thanks to the Principal Dr. MS, Leather Teacher, for the support and guidance. Thank you, teacher. Thank you so much.
Thank you, Reshmi. Thank you.
We are extremely grateful to Dr. T.P. Shashikumar sir for giving a wonderful class on the topic applications and opportunities of analysis. I am sure that this class was a